Hi everyone, in this video we're going to take a look at dividing decimals again with some negative numbers, so let's get started. So let's take a look at this first example. We've got negative 8.84 over 3. So remember when we have a fraction just is the same thing as division. So it's like I'm saying negative 8.84 divided by 3. Now since we're working with decimals, it's always a great strategy to estimate, so that we know what our answer should be close to make sure that it's reasonable. So negative 8.84, I could round that number to negative 9 divided by 3, and negative 9 divided by 3 is going to be negative 3, which means my answer should be close to negative 3. So now I'm going to set up my problem, and I'm going to do this using long division. So I am going to set it up. The number inside is going to be 8.84, and the number outside is going to be 3. Now, before I start with this problem, I can look at my problem. I've got a negative number divided by a positive number. So my answer is going to be, that's right, negative. So since I know my answer is already going to be negative, I'm not going to incorporate any signs into my math part or my arithmetic part here. I'm just going to do positive numbers. So now I'm just going to have to do long division. How many times does 3 go into 8? It goes into it twice. 3 times 2 makes 6. Then I'm going to subtract. 8 take away 6 is 2, and I'm going to bring down. And now I have how many times does 3 go into 28? It goes into it 9 times. 3 times 9 is 27. Subtract, I get 1. Bring down, and I get 4. How many times does 3 go into 14? It goes into that 4 times. 3 times 4 makes 12. Subtract, and I get 2. And right now I've run out of digits, but we know that we can continue adding zeros until we either see a pattern or if this stops, so that I can bring down this 0. And now I have how many times does 3 go into 20? And that's 6. 3 times 6 is 18. Subtract, and I get 2. And again, I've got another 2, so I would have to bring down afterwards. I can bring down another 0, and I have 20. And then I can do this one more time. How many times does 3 go into 20? It's 6. 6 times 20 is 18. And then hopefully we're noticing that we had a little bit of a pattern here. We had 20, and then we had 20 again. We're getting 6 as that repeat. So that means this is going to a repeating decimal. So now, since my estimate was negative 3, right now this is my answer. I've got 2, 9, 4, and a 6, and a 6. And I know that the 6s are repeating, so I can put a bar over it. But since my estimate says this should be close to negative 3, I can now put in my decimal place, negative 2.94, and 6 is repeating, so I only need one of those 6s and the line over top. And this would be my solution for this problem. Now, another way of thinking about where the decimal is, I'm going to bring it up because since some of you might know this already, if you line up your work correctly, this decimal here and the decimal on top, that's how we know we with the decimal. But it's good to estimate because sometimes we don't always line up our work correctly, and then we end up putting the decimal in the wrong place. So it's better to use our estimate to help us know where the decimal should go. So here in our second example, we've got 34.2 divided by negative 2.4. So we know that we have a positive number divided by a negative number, which means that our answer will be negative. Next thing we want to do is we want to estimate, and we've got 34 divided by negative 2, which is going to be an estimate of negative 17. So now that I know my estimate, we can set up our problem. So we've got 2.4, and inside here we've got 34.2. Now notice that we've got a decimal number on the outside, and that's going to be really annoying because how many 2.4s fit into 3? Well, that one's okay, fine, easy, 1. But how many 2.4s fit into 34? That would be kind of tricky. So what we want to do for this is, let's think about this as a fraction still. 34.2 over 2.4. The annoying part is having this out here to be a decimal. So what we want is we want to make our denominator not a decimal. So in order to make our denominator not a decimal, we can multiply by 10, 100, or 1,000 to hopefully make this not a decimal. The smallest one I can do is multiplying it by 10. Because if I do 2.4 times 10, I get 24. And whatever I do at the bottom, I'm going to do the top, so times 10 as well. So 34.2 times 10 is going to be 342. So now that I have whole numbers here, it's a lot easier. And this is okay because they're just equal fractions. They're just proportional. So when I divide them, they're going to give me the exact same answer. So instead of doing this problem that I have up here now, what I'm going to do is I'm going to have 24 on the outside and 342, and now do my long division. How many times does 24 fit into 34? One time. 24, subtract, and I get 10, bring down, and I get 2. How many times does 24 fit into 102? Since 20 times 5 makes 100, I might estimate either 4 or 5 times. So I'm going to do 24 times 5. And I can do 24 times 4. I'm going to go with a smaller one first. 4 times 4 is 16. 2 times 4 is 8, plus 1 is 9, and 96. Actually, that's closer, so I'm going to have a 4 here. And then 24 times 14, we just figured out is 96. Subtract. And 102 take away 96 is going to be 6. And I don't have any more numbers to bring down, so I can put a decimal point here and a 0. And now I've got how many times does 24 fit into 60? I believe that's twice. So 2 times 24 is 48, and I'm going to subtract, and I'm going to have a 10, I'm going to borrow, that's a 5, so that's 1 and a 2, so it's 12, and then I need to bring down another 0, and now I have 120, so how many times does 24 go into 120? Well, if 24 times 4 is 96, probably it's going to be 5, so 4 times 5 is 20, 2 times 5 is 10, plus 2 is 12, so 120, so it fits into it perfectly 5 times. 5 times 24, 120, and I subtract, and I get 0. So I have no remainder. So my answer then for this one, well, we know my answer is going to be negative, so negative. I know my number should be close to 17, and then from my work, I had 1,425. But that doesn't make sense since my estimate says it's negative 17. So that means that right here is the best place for my decimal, and my answer is negative 14.25. All right, so in our last example here, we've got a negative number divided by a negative number, which is going to be positive. Then we can estimate, and this is like let's just round this to negative 6 divided by negative 8. And I'm picking negative 6 instead of negative 7 because if I rewrite this as a fraction, 6 over 8, this is going to be positive. And if I simplify this fraction, I get 3 out of 4. And 3 out of 4, I know, is going to be 0.75 because 3/4 in American money is 75 cents. And another thing to just generalize our estimate, since I have 6 over 8 and this is a proper fraction, I know that my answer will be less than 1. So now that I know my estimate, I can go ahead and I'm going to do my long division. So when I would set this problem up, I would have 6.64 on the outside, and on the inside I would have 8.3. Now, if we think about this, 8.3, how many times does 8.3 fit into 6? How many times does 8.3 fit into 66? How many times does 8.3 fit into 664? It's really annoying because this number on the outside is a decimal, and it's a lot easier for us to work with whole numbers. So if I rewrite this as a fraction, I've got 6.64 over 8.3. The annoying part is that out here, I've got a decimal. So I don't want that to be a decimal. So what can I multiply that by? I can multiply it by 10. And if I multiply by 10, whatever I do to the bottom, I have to do to the top. And then now, I've got 6.64 times 10, which is 66.4. And I've got 8.3 times 10, which is 83. So this is going to make it a lot easier. So this new question becomes 83 on the outside here and 66.4. And now it's a lot easier for us to ask ourselves, how many times does 83 fit into 66? Well, it doesn't. So I could put a 0 here. 83 times 0 is just 0, so I would subtract. I would get 66, bring down a 4. How many times does 83 fit into 664? Well, given that my estimate here says 0.75, the first digit here is a 7, I could maybe estimate that 83 is going to fit into 664 maybe 7 times, or maybe if I round up 8 times. So let's do that multiplication out. I've got 83 times 7, and I've got 83 times 8. 3 and 7 make 21. 8 and 7 make 56 plus 2 is 58. Sorry, 8 and 7 makes 56 plus 2 is 58. 3 and 8 here make 24. 8 and 8 make 64 plus 2, which is 66. So if we look at that perfectly, 8 times. So it's going to be an 8 here, and then 8 times 83 is 664, and I subtract, and I get 0. So now I've got this 0 and an 8 thing. Where's my decimal going to go? So my answer here, I said, was 0.75 as my estimate. So it makes the most sense that I've got 0.8 as my solution for this one. All right, so a couple of things to conclude this video. First things first, estimate. And secondly, sometimes we have to multiply by a power of 10. That means 10, 100, 1,000, etc. Let's put 1,000 there. And this is what I mean here. We have 8.3 in the bottom. We want a whole number, so we would multiply that by 10. We're going to use our division strategy, so whether that be long division or maybe you're better at partial quotient. And then you're going to check your estimate to see if your answer that you got is reasonable, and then absolutely don't forget to double check your signs if you should have a negative or a positive answer.